Hello, everyone, and welcome to our webinar today. Can AI RANvolutionise telco profitability? Evaluating the AI RAN business case. Bit of a mouthful there, but lovely play on words, whoever came up with that. And big thank you to our sponsors, Red Hat, who are partnering with us on this and have an interest and expertise in AI RAN. I'll just take you through a little bit of logistics in terms of the agenda. Bit of housekeeping from me, and I'll hand over to Gabby for a presentation. Then Ignacio will give a presentation, and we'll have plenty of time for a panel and answering some questions I've got. And again, if you have questions, we'll show you how you can ask them, and we certainly like to solicit those from you. And then we'll make sure we're done at or before the hour, 2 o'clock in the UK anyway. Wherever you are, it may be slightly different, so you can rush to your next meeting. In terms of logistics, you are on mute. You're on listen only mode. If you've got a problem with hearing anything, I suggest you come out, step back in. Hopefully, don't have to reboot. But if you've got any problems, then message us in the chat. You can find the chat in the little bar on the right, which you can press in and out using that orange keypad. If you need to raise your hand, you can do that. There's also questions that you can click on. And if you want to submit a question for the panel, you can do that there. And I would encourage you to do that. You won't be named in any way. They'll all remain anonymous. If we can't get to them all, and sometimes we can't, we will ensure we give you a written answer, and we'll distribute that. We'll make the slides available for the presentation to you. And also for all live attendees, there's also the report which Gabby will be drawing her presentation from based on some research we've done on AI RAN and what the business case might look like under different strategies for implementation. So those are available as well, and we'll send those to you in a few days after the webinar concludes. So who have we got on? Well, my colleague Gabby, Senior Consultant at STL Partners, she'll do the presentation. My name's Chris. I'm just, Master of Ceremonies, content free. And we're joined by Ignacio Gonzalez, Business Development EMEA Telco at Red Hat, and Dr. Ardavan Tehrani, who is representing the AI RAN Alliance and works for Samsung Research. And he'll be giving some thoughts on the role of the Alliance and the way they see AI RAN panning out over the next few years. So, without further ado, I'll hand over to Gabby, and thanks, Gabby.
Thank you, Chris. So we actually have done a webinar previously on AI RAN back in May. And in that webinar, we kind of discussed what AI RAN is and the opportunities it might bring for telcos. And I guess the key takeaway from that session was that AI RAN is a really hot topic right now, and early signs are very promising. So following that session, we kind of conducted a series of research interviews with operators, vendors, and other ecosystem players with a goal of kind of exploring the current state of AI RAN deployment and also understanding what commercial opportunities are starting to emerge. And what we wanted to do today is kind of share the key findings from those interviews in today's webinar. So as you may know, there are 3 main scenarios for AI RAN deployment, and each of these represent a different level of ambition and complexity. So first of all, we have AI for RAN, which is a telco-centric model that applies AI internally to optimize RAN operations such as spectrum management, energy efficiency, and fault detection. Then we have AI and RAN scenario, which is all about hosting both RAN functions and additional AI workloads on shared infrastructure. And that is often done to support enterprise use cases, which could create new revenue streams, which is exciting. And finally, we have AI on RAN, which is the most ambitious model where RAN infrastructure kind of becomes an open platform for third-party developers to run and monetize AI applications. So if we look at AI for RAN, early deployments are already proving its value with operators reporting 10 to 30% gains in spectral efficiency and 15 to 20% reductions in energy consumption. And these outcomes are actually really, really important given that RAN accounts for around 75% of a telco's total energy usage. So the savings are significant. However, the direct revenue potential of AI for RAN remains limited, and as I've mentioned, the primary benefit is cost efficiency. As for AI and RAN and AI on RAN, there are several trials going on by operators like SoftBank and T-Mobile, and these trials have shown that running additional workloads on shared infrastructure is technically feasible. And the focus has been on latency-sensitive use cases, such as AI-guided robotics and real-time analytics. However, large-scale enterprise demand for these scenarios, and especially for AI on RAN, is still uncertain. And the vision is very exciting, and a lot of the operators are talking about it, but it does remain a longer-term ambition currently. So while the technical case for AI RAN is becoming a bit more clear through all the trials, operators still face three big commercial and operational questions that will define how fast and really how far the adoption goes. So the first question is, will telcos allow the additional workloads? Because many remain cautious about mixing network and AI workloads on shared infrastructure due to risks around performance, security, and reliability. The second question is whether the compute cost is still a barrier, and AI infrastructure remains expensive and very power hungry, but there are some chips that are falling in price, and there are smaller, more efficient models that are kind of opening up alternative paths. So that is still a question. And then the third question is, where is enterprise demand for AI RAN? Because today, kind of based on our research, the demand for AI workloads on RAN infrastructure specifically is limited. So in the rest of the presentation, we'll kind of unpack each of these questions in a bit more detail and look at what they mean for telcos exploring AI RAN. So when it comes to supporting additional AI workloads, operators are kind of split between two main strategies. So the first strategy is to keep AI workloads isolated on separate infrastructure, and this helps operators reduce the risk of performance unpredictability, avoids potential data leakage, and also ensures compliance with strict regulatory requirements that telcos operate with. And it is considered a safer approach that allows operators to still, pursue AI and experiment with AI, but also protect mission-critical RAN functions while, conducting those experiments. Then the second strategy is to cautiously pursue an integrated approach on shared infrastructure. And this approach allows for better utilization of the existing hardware and can, improve overall economics, since the resources can be shared between RAN functions and AI workloads. However, only a small number of operators are actually moving in this direction, and typically only do that when they're working with a trusted partner ecosystem. And the reason for this is really clear. Introducing AI workloads into live RAN environments brings a lot of complexity. That is a fact. And operators must guarantee predictable performance, maintain the quality of service, and enforce compliance standards. And that is something that many feel is not yet fully achievable with today's orchestration tools. And so to make integration at scale a reality, operators will really need robust guardrails around three areas. So performance assurance, policy enforcement, and end-to-end security. And without these safeguards in place, most operators will probably continue to limit AI workloads to isolated environments. Another critical barrier for AI RAN adoption is the cost of compute. So unlike traditional RAN functions, AI workloads are far more resource intensive, and especially when dealing with unstructured data or real-time applications. So this demand introduces new CapEx, including cost of GPUs and accelerators, greater memory bandwidth, and also high-speed networking infrastructure. And then at the same time, it also raises the operational expenditure, since you need more power, more cooling, more space, and also ongoing maintenance. to keep those systems running efficiently. So for many operators, this makes that large-scale AI deployment a little bit financially challenging. But then on the other hand, there are some signs of progress. So, the chip prices are falling and more efficient grade accelerators are being developed, which is making it possible to run, for example, lighter AI tasks without the same level of upfront investment, and then only investing in high-end chips when the enterprise demand becomes more clear and the commercial model becomes a bit more clear. In practice, though, this kind of leads to a hybrid infrastructure model that many operators are starting to adopt. So in that model, CPUs continue to handle orchestration and standard RAN functions, while GPUs or other accelerators are kind of reserved specifically for AI workloads. And this balance specifically allows operators to manage costs while still building AI capability on the RAN infrastructure. And this is something that we've heard from several players as something that they're thinking about. And then the final question we explored in our interviews was, where is enterprise demand for AI RAN? And I guess today, demand is still concentrated in specific verticals and use cases, particularly where three requirements are critical, and those requirements are low latency, data locality, and privacy. And these are areas where cloud or centralized AI solutions may not be sufficient, and where running AI within the RAN itself can really provide the value. So for example, if we look at some of the example scenarios and use cases, so in manufacturing, AI-powered robotics require ultra-low latency to operate safely and efficiently, and any delay in processing could really disrupt production or even cause safety issues, which would make AI RAN here a very strong fit for them. Then if we look at retail and logistics, real-time tracking and optimization of supply chains really depends on processing data locally and quickly. So AI RAN in this scenario would allow enterprises to make time-sensitive decisions without really depending on distant cloud infrastructure. And then the final use case that we've kind of heard throughout the interviews was around government and public sector, and specifically thinking about secure video analytics, which is an important use case there. And in this case, privacy and sovereignty requirements mean that data really cannot leave the local domain. And here, AI RAN would provide a controlled environment for processing that sensitive information at scale. What this kind of tells us is that enterprise demand is not yet very broad-based. Instead it is kind of highly concentrated in sectors where latency, locality, and privacy are essential, as mentioned. So what this means for telcos is that really working closely with a small number of enterprise partners will be critical in the early stages. And by collaborating directly, operators will be able to validate which of the use cases can truly benefit from AI RAN and identify the commercial models required to support them. And these partnerships will also provide a practical way for telcos to test orchestration platforms, workload management, and all the service level agreements before committing to large-scale deployments. And then over time, as these proofs of concept mature, operators can then build the confidence and the technical capabilities needed to expand AI RAN adoption more widely. But I guess for now, working with a few enterprise customers is seen as the way to go. So as part of this research to assess the commercial viability of AI RAN, we also modeled 3 AI RAN deployment strategies using a representative medium-sized operator with annual revenues of 7.5 billion and a network of 15,000 cell sites. And the objective here was to estimate how much financial benefit each of these scenarios must generate over 10 years to break even by year 6 specifically. So if we look at the AI for RAN, this model requires around 150 million in peak funding by year 3, and by year 10, it could bring a modest incremental revenue uplift of about 2%, which is driven primarily by cost savings. And I guess while it's not transformational, this path is credible and low risk, which makes it the most practical starting point for many telcos. Then if we look at AI and RAN, this model requires roughly 300 million in peak funding by year 3. And by year 10, this could deliver an incremental revenue uplift of around 5%. However, as discussed before, the success here really depends on demand materializing from enterprise customers and very strong alignment with ecosystem partners. Then the AI on-RAN model here, which is the most ambitious one, it requires almost 600 in peak funding by year 3. But again, the upside is also very significant with more than 11% incremental revenue uplift by year 10. That is obviously provided that adoption scales across enterprises and developers. But obviously, it is worth noting again that this path carries the greatest execution risk. And again, at present, the enterprise and developer demand is a little bit uncertain and the commercial models are not yet proven. So I guess overall, the takeaway from this analysis is that AI for RAN is the most practical entry point for telcos today, and it delivers real near-term value and reduces operational risk while creating the foundations for operators to expand into more ambitious AI and RAN and also AI on RAN strategies as ecosystems and demand mature. So we discussed several questions, that telcos need to answer and looked at the scale of financial impact to make AI RAN a reality. But what does this all really mean for telcos? And I guess there are 5 key recommendations that telcos should keep in mind as they look to enter the AI RAN space. So first of all, we think that telcos must really engage in the ecosystem design, and they need to play an active role in shaping standards, governance, and also interoperability frameworks if they want to play a role in AI RAN. Second of all, they need to get closer to enterprise customers because many enterprise use cases sound promising in theory, but telcos must really validate which ones truly require AI RAN's capabilities, and that can only be done in close partnership with enterprises. Third, we think that telcos should start with AI for RAN, as mentioned before. This is the most practical entry point, which would enable them to build operational maturity and, establish strong internal foundation, which will put them in a good position to expand into more ambitious hybrid models and also external service offerings over time. Then fourth, we think that telcos should really monitor early leaders such as SoftBank and T-Mobile because these operators are already experimenting with orchestration, with ecosystem partnerships, and also some of the commercialization approaches, besides the obviously trying to prove the technical feasibility. But learning from their strategies can really help others accelerate their own journeys. And finally, what is really important is having internal alignment because AI RAN cannot succeed if it is confined to pilot projects which are run by siloed teams. So RAN engineers, AI specialists, enterprise sales, and strategy functions, everyone else really need to be collaborative. They need to have clear ownership and incentives to make this a reality. So in short, I guess telcos today face a critical window of opportunity, and we think that by starting pragmatically with AI for RAN, they can capture near-term efficiency while laying the foundations for more ambitious AI and RAN and AI on RAN models in the future. Yeah, thank you. That's it from STL side, and I will now hand over to Ignacio from Red Hat for his presentation.
Okay, let me unmute it. Thank you, Gabi, and again, thanks for having me. Unfortunately, Gabi, you have to be my clicker, so let's see how we can synchronize each other. So I'm Ignacio Gonzalez. As Chris was mentioning, I am part of the Red Hat family. I'm part of the Red Hat Telco Center of Excellence, and I am responsible for mobile networks business across the EMEA region. Okay, so as I said, I'm thrilled to be part of this webinar. So Gabi, let's go to the next slide, please. Yeah, nothing new. Let's start with the same slide that I used in the previous webinar, which is coming from the AI RAN Alliance with the 3 working groups that they are working on. Gabi explained very well all of them, and I'm not going to go through them, but if you click once, Gabi, today we are going to be, I am going to be focusing on AI on RAN. So probably the one that in terms of revenue could be the big one, but at the same time when we can see more challenges coming there. So the AI on RAN is dedicated to identify these key RAN requirements to deliver and benchmark AI applications over RAN connectivity and infrastructure. And a key aspect of this working group is the role of the network differentiator, connectivity, and the device capabilities, which are essential to enhance the quality of experience for AI-powered applications. So we are talking about, in a nutshell, in how to provide connectivity to AI devices. There are 4 focus areas. I'm going to try to summarize it in 3. The first one is about the AI-based multimedia applications, be it analytics, augmented or virtual reality, immersive gaming, etc., etc. The second one is about AI-based security and critical applications. It's about, for instance, enhance the security application in terms of intrusion detection or support critical healthcare applications. And the third one, it's purely about AI for automating industrial operations and manage autonomous vehicles. Okay, there are more, but to me, these are the 3 more important. One click more, Gabby, please. Okay, so what I'm going to try to explain here is how telcos, they should embrace what I call the AI arena, right? There are 3 different components here. At the left, you have the devices, the AI devices. In the middle, the different type of telco sites. And at the right, the hyperscalers as itself. And I'm going to use them as a benchmark, right? So one click more, Gabby, please. The first layer that we are going to check is the cloudification. And here, as you can see, the level of cloudification of hyperscale is very high compared with the telcos. Probably in the telco data center, it's it's medium, more or less the level. Probably in the edge telco data center, which is relatively new compared with the data center, is slightly higher because they have embraced visualization and containerization and cloudification since day one, and very low in the far edge or for the RAN sites. Okay, let's see the next level. So click again, please. Automation or AI, let's say end-to-end automation. And when we talk about end-to-end automation, again, hyperscalers, it's significantly high compared with what telcos are doing. That it could be in the mid-low level. And if we click another one, probably here the name of GPUification is not the best one because we are talking about the AI infrastructure. So yes, we can talk about GPUs, but we can talk about CPUs, DPUs, accelerators, etc., etc. So maybe forgive me about the name. Let's say AI infrastructure. And again, there's a high difference between what is the current status of and level of the hyperscalers compared with the telcos. And the final one click, Gabby, here is about the AIification, or let's say the number of, not only in terms of AI applications, but also how they can embedding, or how they have embedded end-to-end AI in the infrastructure. Again, very high for the hyperscalers, very low for the telcos. When I talk about automation, I'm talking about end-to-end automation. So it's true that many RAN software, you can get let's say different features to automate, but I'm talking about an end-to-end, the overall site, not just only the RAN side. Okay, just one comment because it's important. So final click here, Gabby. So if telcos, they really want to get this amount of money, this is coming from STL. It was an analysis made by them at the beginning of this year, but we are talking about that by 2030, around $160 billion. So the question mark is, if telcos, they want to embrace and they want to grasp part of this revenue, well, there are many things that they have to do, because in terms of this, as you can see, the current situation in terms of the level is not really great. However, at the same time, telco advantages in this edge AI arena. The first one is the proximity and the low latency, because the way that the infrastructure is distributed, you can see the far edge and the telco edge provides proximity to end-to-end users and also to the data, which is crucial for the real-time AI applications. So this allows for a much lower latency compared to sending back all the data to the centralized cloud. The second one is data sovereignty and trust. And because telcos are often seen as trusted local entities, and they can address concerns about data privacy and security in a much better way than maybe other entities. Many countries and enterprises prefer to keep this sensitive data within their borders, and telcos can provide that assurance. And again, we are seeing what's going on right now here in Europe, what's going on in terms of the gigafactories that the European Union is trying to get, where telcos, they potentially play a significant role. And the third one is about existing customer base, because operators can leverage their existing relationships with enterprise clients to upsell AI services. For example, if a telco could offer to a manufacturing company not just a private 5G network, but also an AI application to host edge, or to deploy AI applications like, for instance, quality inspection via video analytics. So, and again, there's these three components that in a certain way, they can put telcos in a very good position. However, they're gonna need to invest in order to be ready for that. Next slide, please, Gabby. Okay, here, let me talk about something that is quite important and interesting, which is how to leverage this AI. And for that, there is a concept, which is the AI inference, that we believe it could be crucial in order to deliver these AI applications closer to the customer, to the enterprise, because AI inference delivers business benefits by enabling fast localized decision making. It can reduce the operational costs, as we're going to see later. It will improve security and enhance the user and customer experiences. Three components or three areas to highlight it. The first one is the real-time data processing and lower latency, because AI inference allows organizations to process data and make decisions instantly, which is critical in use cases like manufacturing automation or healthcare monitoring. It's also about low latency improves applications responsiveness, support sensitive services, and can create superior customer experiences. Second one is about a cost efficient and bandwidth saving, because processing data locally, especially at the edge, business can reduce the amount of data transmitted to cloud servers, saving bandwidth and cloud storage cost. And also, inference reduces the need for large-scale data transfer, lowering infrastructure operational and network upgrades bills. And finally, and we talk about again, is about enhance the security privacy, because it minimizes transmission of sensitive data, helping to ensure regulatory compliance, right? Okay, key aspects when we talk about how AI inference can help telcos to go for this AI proposition and market. Next slide, please. Okay, so now this is a call for action for the telcos in terms of this AI native RAN, and 4 actions that they need to bear in mind from our point of view. The first one is that telcos needs to define a clear strategy path for Edge AI and AI native RAN. Why? Because they need to have this AI-driven transformation. That's something that we have seen, is something that is new, and they need to address in a much better way. And this includes defining a specific milestone and also developing this roadmap for this AI transformation journey. The second one is a cloud-native architecture. We have seen that the goal is to build a robust cloud-native architecture that can support both RAN workloads, but also other type of applications like the HAI applications. So telcos, in a second point, they need to explore and identify these new opportunities that the HAI and the HAI inference can bring. So telcos aim to monetize their telco infrastructure by leveraging the AI at the edge. That's again something crucial. Again, if they want to be positioned as a key figure here. And also telcos should position their AI services as a differentiator in the market, for instance, versus hyperscalers, right? So the third one is that the telcos, and Gabby also mentioned this, is that telcos, they need to engage with their key enterprise customers to understand the needs, the pain points, and try to identify these relevant new use cases where AI can be used. And the final one is strengthening the AI ecosystem and innovation. So this involves to participate in industry consortia like the AI RAN or the Global Telco AI Alliance, and more probably industry consortium that we're gonna have. And the second one is the open source and upstream projects. telcos should also actively involve themselves in open source and upstream AI projects. Why? Because in many of them, for this upstream project is when the innovation is coming, and also they can influence if they know what's going on and they understand what are the needs, and they can influence things they want. So I'm talking about also being part and understand what's going on Hugging Face in terms of different language model, projects like the VLLM or the LLMD, that again, they're gonna define what is gonna be the next steps, for instance, in terms of the AI inference that I was mentioning before. So in a nutshell, several operators have launched AI inference services from regional data centers to the edge sites, and they were able to demonstrate that this is a viable concept and it could work. And the final slide from my side, Gabi, please click, is what Red Hat is bringing here. And because sometimes it's not about, and here I don't want to say what we have in terms of AI infused capabilities in our product, which of course we have, is about how we are helping and addressing these AI challenges. So our proposition lies on 3 pillars. The first one is the Red Hat Inference Server, which is aimed to optimize inference at scale, thanks to the VLLM project that I mentioned before. Second one is the Red Hat Enterprise Linux AI, about tuning and serving large language model and also small language model in a single machine. The final one is the Red Hat OpenShift AI, which includes, of course, the Red Hat Enterprise Linux AI and the Red Hat Inference Servers. And at the end, it's a full setup for a complete generative AI and predictive AI solution, no matter over what infrastructure, as you can see here, and also no matter where do you need it. Could be in a hyperscalers environment, could be your data center, could be in your telco edge data center, or in the future in the far edge. So that's all from my side. I hope I gave you some interesting points here. And now I'm looking forward to joining to the panel. So thank you so much. And over to you, Chris.
Brilliant. Thank you. If Ardavan is awake, because he's in the west coast of the US, so it's 5:30 for him in the morning. He's been up for a little while. And thanks for that, Ignacio. Ardavan, why don't we turn over to you, and why don't you introduce yourself, both your roles at the AI RAN Alliance and also at Samsung, and a little bit about your involvement within those capacities on this topic.
Sure. Thank you, everyone. Hi, everyone. I'm Ardavan Teherani, and before I go through the background, let me say that it's a pleasure to be here, and thanks STL Partners for having me here. I am with the 6G research team at Samsung. In that capacity, I'm active in some of the US related 6G related activities for Samsung Research, and that includes serving as vice chair of the AI RAN Alliance board. In that capacity, I'm active in a number of board committees and some of the Alliance working groups. I'm also serving on the board of US ITU Association, which is the standard body ITU is a standard body that initiates basically the next G standardization process that eventually for RAN goes to 3GPP. I'm also representing Samsung on FCC Technical Advisory Council. In that capacity, I've been co-chairing one of the AI ML working groups on softwareization networks. And I'm also a member of FCC WRC Advisory Committee.
Wow, and probably lots of initials after your name, I'm sure. Research man. I'm really interested in understanding. We've had a lot of punchy questions, and we'll get to some of those. But let's sort of build this up step by step, because there's lots of activities and benefits that more intelligence in the RAN can bring. And maybe if we start with a simple one, the AI for RAN, or the way I tend to think of it is sort of telco centric. This is about more intelligent compute in terms of being able to run the RAN more efficiently and effectively. We know that telcos are under pressure in terms of OPEX and CAPEX, business models, prices are not rising, revenue is slowing. Have you, either or both of you, seen examples where AI specifically is demonstrating reduced CapEx and OpEx in telecoms networks? And if so, is that in the lab? Is that in pilots, or is that now commercially being deployed? It'd be great to get your views on that. Perhaps Ardavan, we'll kick off with you.
Sure. So let me mention, by the way, this is a great question, by the way. So we also have another name for this. We call it AI native. And the idea is that AI would be core part of the functionality, and both functionality and operation of the networks. So some of the areas that we in the RAN Alliance are focusing on, and that's also true for the whole RAN ecosystem, is, I think Ignacio and Gabby mentioned, is this area of efficiency in power consumption, efficiency in operations. Those bring some obviously OpEx reductions. But there are also network automation aspects of using AI. And those are also another aspect of it, is basically more operation automation would bring other efficiencies also to network operations. Examples of that is predictive maintenance, self-configuration, self-healing, self-optimization. And I should mention that a lot of these kind of network automation functionality has been around for some time. I can tell you that on a personal level, I was involved in this AI-based network automation almost 10, 15 years ago. And that was for broadband networks. And we had customers deploying these solutions. AT&T in the US, there was a Telefonica group, in Europe, Sky actually in the UK. What has changed is this new capabilities with AI and compute and hardware infrastructure, and also this trend of cloudification and visualization that now is enabling this solutions to be deployed and integrate with the networks much better and in much more cost effective than 10, 15 years ago. So there have been examples, but we are taking it to a next level.
Okay, and just so we understand the time frame here, obviously we're towards the end of the 5G cycle in terms of deployment, still not done yet. There are still plenty of networks out there that aren't standalone 5G and so on. But is this really about, you talked about AI native, is this really a 6G standard in terms of incorporating the technologies that are available, new chips, new accelerators and so on, into the 6G capability? And that is a given. In a sense, the investment that telcos are inevitably going to make in the 6G cycle, is that part and parcel? AI is going to be built into that RAN. Is that what we're really saying? And what we're seeing at the moment is some of the tests as to how far that could be pushed in terms of new use cases opening up to third parties. But essentially, if you're a telco, you're doing exactly the same thing you are today, which is providing great connectivity services. Is AI RAN part and parcel of that de facto?
Yeah, that's a great question, by the way, because the feedback we get all the time from the operators is that they do not want to spend, huge amounts of money to upgrade the 5G into 6G. So there is that kind of.
They always want that, but it's kind of,
But so what is happening? I think elements of these AI functionality could be deployed in 5G networks. And so there are elements of it that is going to get into 6G, or for example, a lot of AI for RAN functionality, the AI native aspects of it, those are the functionalities that is part of the design of the RAN functionality. So I can give you examples of it. Some of the ones that are getting into 3GPP standard is new modulation schemes, AI-based modulation schemes. These are different from QAM modulations. These are not going to get into 5G because the standard has to change. There would be interoperability issues. But there are other functionalities like network operation automation or predictive maintenance. As I mentioned, these have been already in the networks in the past. So those are functionalities, AI-based functionalities that could get deployed within existing 5G networks. So what we expect to see is a gradual transition of AI deployment in the networks from the AI functionalities that could get deployed in 5G networks to functionalities that would require more advanced integration into the RAN network architecture, which is going to take longer term. And those would go into 6G.
Right. Okay. And does that then open up? Is it 6G that then opens up the opportunity for third-party AI workloads being run on that shared infrastructure, or could that happen under the 5G scenario? So is AI for RAN a bit more of a here and now that could start earlier, and the third-party AI and RAN, AI, I mean, I find these like mind-blowing, these terms, but the third-party workloads, AI applications being run in the RAN, are those only possible on 6G? Is that what we're saying?
You know, no. So, Ignacio, do you want to answer that, or I can also answer the question?
What I can add here is, Chris, if you check right now, for instance, what is happening in terms of the O-RAN alliance with the RIC and with the XApps and AirApps. So we can see that they are infusing AI in certain applications there. So you don't need to wait all the way to 6G. That happens. So and also Adam mentioned before a long time ago that I have seen AI features already embedded as part of the RAN software from the different vendors. So what we are seeing in the last years is that thanks to the disaggregation of the different components of RAN, for instance, what the O-RAN Alliance is doing, they are opening and creating different network functions with different roles, that the idea is that they should be able to interconnect between different vendors. So this vendor interoperability is going to be there, plus the possibility of deploy that in a cloud network or in a virtualized platform, whatever you're going to call it. All this together has already embraced for these first starting points of what you mentioned, the AI for RAN.
But that's all about, the RIC is all about running the network more efficiently and effectively. Yes. I kind of absolutely get that. That's AI for RAN. Absolutely get that. That's starting, that's part and parcel. I think what people are quite intrigued by is the promise of being able to open up new revenue streams by deploying AI workloads on telco infrastructure. It was the kind of MEC, 8 years ago we were talking about MEC, never happened. Is this, now, if this is possible, and there are lots of barriers, and Gabby went through some of them, is that only possible under the 6G scenario, or could that be something that's leveraged under a 5G? Is it here and now? That's what I'm trying to understand.
Yeah, we completely understood that. So let me also add to what Ignacio mentioned. 5G network slicing is an example where AI-based network slicing is, it's not a 6G, is not a 6G only solution. There are actually trials happening. There are basically solutions developed for 5G, for network slicing. It's using 5G networks, and a lot of it is also for enterprise applications. This is where you use, and a lot of it is actually also Gabby had in her presentation, latency specific or latency sensitive applications that you can do that. I should also mention a lot of trials you're seeing on AI and RAN. These are multi-tenancy or shared infrastructure implementations of AI and RAN. They're actually, the trials are happening on 5G networks. So these are basically private 5G networks that they're showing the trials.
SoftBank and so on.
Yes, SoftBank, NVIDIA. There are actually trials and demos actually
But these are pretty early stage, and they're not commercial implementations in any way. They're a long way from that, as my understanding.
Yes, so they're in trial stage, but my point was that it's not 6G. This is 5G. Yeah.
And if I may, Chris, going back to SoftBank, it's better to talk with SoftBank about what they planned, but I'm pretty sure that they are not going to wait until 6G is here to deploy all of the multi-tenancy capabilities that they are working on. It's true that maybe SoftBank could be considered as a special case because they have the huge support from NVIDIA and AMD. Totally right. But at the same time, they are proving that this multi-tenancy, where one single platform can deploy with a certain orchestration at the top, they can dynamically share the infrastructure for AI applications or run workloads. It is working. And I'm going to give you one example, and maybe Japan is an extreme example of what is happening in other parts of the world, because by default fiber is everywhere because they are centralizing the RAN as much as they can.
And you need fiber presumably to the base station if you're doing it there, or because otherwise you haven't got the capacity to be able to manage those kind of heavy duty workloads.
I think I have this debate about the fiber for the mobile sites like 25 years ago. So it's obviously that we are going to need, if you want, capacity is growing, the traffic is growing, it has been growing over the last years, and it's expecting that it's still growing. So there is the need of fiber there, and also there is a need of an optical layer for sure. That's something that we're going to need if we want to achieve this. So, but that's something that whether or not you're going to go for an AI RAN, you're going to need to do. Because the traffic is still growing. My point here is, if you think about, if you're able to centralize your RAN in one single, as I mentioned before, edge data center, and in this edge data center, you want also to provide other AI applications for other customers. You mentioned before the edge computing or the private networks, or et cetera, et cetera. The question mark is how much of this infrastructure can be shared, because if I can share the infrastructure for the RAN workloads together with other AI applications, of course, I need always to prioritize the RAN traffic, because otherwise I'm going to be in trouble. And as I mentioned, you need to have a right orchestrator capabilities on top of that to manage this. You're going to be able to save in infrastructure. We know that the RAN capacity is working in peak times, maybe 20% of the time. The rest of the day, it's in low valley. So you're going to have there a certain remaining capacity free. So the question mark is what we can do with this capacity that is not used. So we need to think about it. It's not about forcing telcos to go with the RAN about that. It's about how we can get the most of this infrastructure that we are not using, or telcos are not using many hours to use in other ways.
That's a really interesting point. But here's the thing. We've had lots of questions on this. Just because you can do something technically, does it mean that customers will buy what you can offer? You know, you've got spare capacity, but you haven't got guaranteed spare capacity exactly when customers want it, because you may need to use your capacity. You may get a traffic spike because the World Cup's on or whatever it happens to be. So I think the key question here is what are the use cases? And we've had quite a few questions. What are the use cases and the potential revenue streams that AI RAN offers that you can't get in a telco AI factory or a regional data center that is set up for artificial intelligence? And I think this is where people are asking a lot of questions, because they're sort of saying, well, you built up this model, which it's an STL model, and we've looked at incremental revenues and the incremental costs and so on. I'm very happy to take you through that. It's quite detailed, so it's difficult for me to offer a simple answer. But they're going, look, there's a significant investment in moving from running telco workloads and telco network requirements with a more sophisticated infrastructure that incorporates AI. And we can do that for cost reasons. But the moment we start getting into revenue generation, it requires significant incremental capacity, because you've got to have a capacity there guaranteed for your partners, your customers. You've got to have more emphasis on more expensive GPUs, because you're doing AI stuff. You're not mixing GPU and CPU type activities, what you need to run the RAN, because you can do a lot still using CPU in, you know, in the actual cell tower and so on. So I think people are really struggling with trying to understand, okay, in theory, we've got a big opportunity here. Is there really demand there? And at what point do we make the investment? Because, you know, it's a big step from introducing more intelligence into network functions to jumping to, whoa, there's big revenue upside here. And I just wonder whether you guys had any thoughts on that, or any examples of new revenue streams now from AI RAN or machine learning in the RAN that would be useful for people to point us for folks. Sorry, long question. Ardaban, Ignacio, any thoughts?
Maybe, yes. So these are all valid questions, by the way. You know, with any new technology, you would also face challenges in, both technical challenges and also, the business cases. But there are certain use cases that, at least in the Alliance, we have been thinking about. By the way, I should mention that our focus in the Alliance is on enabling basically AI for RAN. But then we are not addressing the business use cases, and this is up to the operators, and and they don't like people to tell them what to do. But so let me mention some of the use cases or revenue streaming opportunities that we think is very AI focused, and with AI RAN, it's potentially possible to offer them. So I already mentioned network slicing, right? For 5G, 6G network slicing. I think that's something that has happened or was promised for 5G, but there's potential to also extend that with AI capabilities. One thing that Ignacio mentioned before was the edge AI services, and these are really applications that you need edge capabilities to enable these AI services. And he mentioned video analytics. There is also this services for UAVs, connected drones, and also enterprise edge services. So that's one of them. The other one, which I think people have started to talk about, is this Gen AI, right? Or they call it telecom, Gen AI for telecom, LLMs and RAG services. So this is basically more LLM based or Gen AI based services that you can run them on the telco side, and they part of this is basically part of automating the network operation for telcos, but part of it is also edge services for enterprise, AI powered services for enterprise applications, LLM based ones. And that would require having AI compute capabilities on the RAN. So there are a number of them, and of course, you could also potentially, if you have this hybrid architecture, if you have multi-tenancy architecture, the edge GPU infrastructure could be also be provided as a service. This is infrastructure as a service, right? So these are the ones that we are exploring, and are a few examples. But as you said, I mean, this is going to take time to prove, and I don't think anyone right now has any implementations that could prove the business case. But these examples are ones that are very AI specific. So 5G networks are not capable of providing them.
Ignacio, anything to add?
Yes, Chris, yes, because I think we are nearly at the end of the time. So very quick. So if telcos are embracing today edge computing, and they are talking with their customers about how they can deploy certain use cases, they're going to be in a much better position to go later on in these AI RAN. So this is not about a full bang that since day one you need to go all the straight to AI RAN. So I think this is a step by step, and that's what I was mentioning before in terms of creating these milestone and roadmap. It's going to take years to reach that. And the first step is, okay, understand which kind of applications telcos they can deploy at the edge, purely applications. Few of them could be AI, certain ones not. And later on, let's see how they can evolve there and try to integrate both. But as I said, I'm just to be perfectly clear, I'm not promoting here, hey guys, you need to get rid of your current network and go for a GPU-based network. That's not the case. The case is you need to start working first in the edge computing, start working there with 2-3 use cases that your customer, and Ardavan mentioned before, it's about telcos talking with their enterprise customer, they're gonna implement and see this is how it's gonna evolve. And later on, in a certain point, AI and RAN will come into the picture, and they will see that how can leverage this and implement this. This is, from my point of view, the right steps to follow.
Thank you. That was really useful. I mean, we've had lots and lots of questions here. We have had a chance to Hans Dieter, Rani, Ahmed, Wolfgang. We will get to those questions. We will give you written answers and potentially a different perspective from STL, the AI RAN Alliance, and Red Hat. No harm in that. We can certainly give you different views. I mean, I think we all know that AI inferencing is pushing more compute in a distributed direction. That's really clear. We're seeing that with regional data centers. We're seeing that growing. It's also causing infrastructure to become more specialized. So we are starting to see different types of edge or distributed compute solutions. I think from a telco perspective, it's clear that deploying more intelligence in the RAN is part and parcel of business as usual. It's going to have to happen. It's already happening, the RIC and so on. The key question, I think, that still remains is, what is the incremental advantage that telcos have of having potentially more intelligence deep in the network, very close to the edge? Are there use cases that attract a premium in terms of what they can offer above and beyond other distributed compute solutions? I think, you know, what the AI RAN Alliance and others are showing is it's possible to do this. It's possible technically, and it's possible to do it today. There's clearly a cost associated with it. The key question remains a business case question, is, you know, as you get more ambitious and you want to do more, and that's what we've done with modeling, the costs go up quite incrementally, and therefore understanding and managing risk, and probably starting with something that is about doing networking more efficiently and more effectively, makes absolute sense. That's business as usual. But evaluating the demand side and the investment and costs for doing more and taking on third-party AI workloads is something that needs to be evaluated on a step-by-step basis. That's kind of my personal view. And, you know, I guess what I'd like to say is thanks very much for a great and very engaged audience. I'm sorry we didn't get a chance to ask, you know, you put a lot of time into the questions. They're quite long, and trying to process them was not easy. We will get to them. Big thank you to Ardavan and Ignacio and to Red Hat. And we'll send out the report. We'll send out the presentations. We'll send out a Q&A over the next days. And please do get in touch if you want to go through the model in more detail. Happy to do that. But thank you very much, and away to your next meeting. So give you 2 minutes back. Cheerio.
Thank you very much.